Hello and welcome. In this video we want to talk about infinite limits. Infinite limits and vertical asymptotes are directly related to each other. But in this video our focus is only on infinite limits. We talk about vertical asymptote and infinite limits in another video. Suppose we want to find this limit of 1 over x to the 2 as x approaches 0. Before we find this limit, let's take a look at the graph of the function y equals 1 over x to the 2. Graph of this function is something like this. This shows the graph of 1 over x to the 2. And here we want to find the limit of this function as x approaches 0. Attention, you don't need to know the graph of this function, but here it helps to get why the limit of this function is infinity. If you look at this graph, what you can notice is that if you approach to 0 from the right or from the left, this is a two-sided limit. So when x approaches 0, it can approach 0 from the left and it can approach 0 from the right. As you can see, when we approach 0 from the left or from the right, in either case, the y value of the function approaches to infinity. So, from the graph of this function, simply we can conclude that the limit is infinity. When x is very close to 0, in the left side of 0, the y value is very large number, and if we are in the right side of 0, very close to 0, also the y value is a large number. So this means that when x approaches 0, the limit of 1 over x to the 2 as x approaches 0 is infinity. So f of x increases, f of x in this case is 1 over x to the 2, increases without bound. When things like this happens for a function, we say the limit of the function at that point is infinity. And actually in this case, x equals 0 is the vertical asymptote of the function. Now we want to know how we can find this limit without the graph of the function, because normally we don't know a graph of function, especially if the function is complicated. When x approaches 0, usually, for finding limits, the first thing we try to do and find the limit is direct substitution. What happens if we plug in 0 for x here? We are going to get 1 over 0. We know that any non-zero, we know that when the denominator is 0, the fraction is undefined. But attention, here x is not 0, x approaches to 0. And so this 0 in the denominator is not really a true 0, it's just close to 0. And when we have a fraction that the numerator is non-zero, the denominator approaches 0, the value of that fraction approaches infinity. So basically we have this general rule that we need to know for many questions, and it can help us to find many limits. When we have any number, but attention, non-zero number. So if we have any number but non-zero over something that approaches 0, again this is not a true 0, it's just something that approaches 0. So if you have a fraction, the top is non-zero, the bottom approaches 0, then the value of that fraction approaches infinity. But of course it can approach positive infinity or negative infinity. We will discuss about this in more detail later. But let's back to this question. Here, the numerator is 1. The denominator approaches 0, so the limit is infinity. If you know this rule, simply you can answer this question without knowing the graph of the function. But let me tell you why this happens. Why when we have non-zero over something that approaches zero, it becomes infinity. It's very simple. If you plug in a number close to zero for x, you will see what happens. Let's say, for example, we suppose x to be something like 0.1. If we plug in 0.1 for x here, then we have 1 over 0.1 to the 2. 0.1 to the 2 is 0.01. So this equals 1 over 0.01. 1 over 0.01 is equal to 100. Why? Let me explain you. We have 1 over 0.01. You can say instead of 0.01, 1 over 100. It's the same number. Now, if you want to do this division, you can say, okay, this is like 1 times reciprocal of this. Reciprocal of 1 over 100 is 100. 1 times 100 is 100. So, as you can see, when the denominator of a fraction is becoming smaller and smaller, the value of that fraction gets larger and larger. It increases without bound. If we try another number closer to 0, the value of the fraction would be larger. For example, if you plug in 0.01 for x, then we have 1 over 0.01 to the 2, and if we calculate this, this would be 10,000. So when x approaches 0, the value of 1 over x to the 2 approaches infinity. But the final thing that you need to remember to find these type of limits is this golden rule here. Any non-zero number, any non-zero expression over something that approaches 0 goes to positive or negative infinity. Again, I have to emphasize on this that the denominator approaches 0. It's not equal to 0. Because if in the denominator we have 0, it would be undefined. But this is, by this 0 here, we mean something that approaches 0. Let's see how we can use this trick to answer similar questions. Now we want to find the limit of 4 over x minus 2 as x approaches 2 from the right. First, we do the direct substitution. If we plug in 2 for x, we would have in the denominator 2 minus 2, which is 0. So actually we have 4 over 0. Non-zero over something that approaches 0. Attention again, this is not 0. When x approaches 2 from the right, x minus 2 just approaches 0. It's not truly 0. It's close to 0. And based on this rule that here we have, any non-zero over 0 approaches infinity. So we say, because the denominator approaches 0, we can conclude that this limit is infinity. But is it positive infinity or negative infinity? You can find it based on the way x approaches 2. X approaches 2 from the right. This means what? This means x is close to 2, but it is greater than 2. Something like 2.01. You can imagine. This is not mathematically right to say x is 2.01. But in your head, you can suppose x is something like 2.01. 2.01 minus 2 is a positive number or negative number? It's a positive number. So, when x approaches 2 from the right, x minus 2 approaches 0 from the right. So, the denominator is close to 0, but it's a positive number. We have a fraction that the numerator is positive. The denominator is also positive. So, we can conclude the fraction is a positive number, and so the limit is positive infinity. Infinity is not a number, but we say limit is infinity, which means that when x approaches 2, this function increases without bound. And we say the limit is infinity. We don't say the function is infinity. We say the limit of the function is infinity. So as you can see, by this golden rule, finding these type of limits is very simple. We do direct substitution. Denominator is 0, so the limit is definitely infinity or negative infinity, but you have to figure out positive or negative infinity based on the value of x. Let's do another question. Now suppose we want to find limit of same expression, but now x approaches 2 from the left. Probably you can guess what would be the answer. We would have 4 over 0, but because x approaches 2 from the left, x is less than 2, something like 1.9. Minus 2 will be negative. So the top of the fraction is positive, the bottom is negative, so the limit would be negative infinity, because when we have a fraction and the fraction is negative, the limit should be also negative. So this limit is negative infinity. So in general, if we had this question, what would be the answer? What is limit of 4 over x minus 2 if x approaches 2 from two sides, from the right and the left? As you can see here, the limit from the right is infinity, from the left negative infinity. So from the two sides, because we have different limits and actually the limits are infinity, so what would be the answer of this limit? This limit does not exist. Attention, when we say the limit is infinity, this doesn't mean that the limit exists, but we say the limit is infinity. It's right. But here you cannot say the limit is positive or negative infinity, because from the right the limit is positive infinity, from the left is negative infinity. So from the two sides the limit does not exist. Let's do another question. We want to find limit of x approaches 1 from the left, 2x plus 1 over 1 minus x to the 2. What is this limit? Simply we do the direct substitution. We would have 2 times 1 plus 1 over 1 minus 1. Then we have 3 over 0. We can have this reasoning. When x approaches 1, the denominator approaches 0. When x approaches 1, the denominator approaches 0. And numerator is non-zero. In a fraction, if denominator approaches 0, but numerator is non-zero, that fraction approaches infinity. The function approaches infinity. Now is the time to figure out, is it positive infinity or negative infinity? Because x approaches 1 from the left, it means that x is close number to 1, but a little less than 1. We can imagine something like 0.9 or 0.99. When we have 1 minus 0.99 to the 2, this number, when you raise it to the 2, still is less than 1. So if we calculate this, if we subtract 1 from this, this would be positive. So the 0 that here we have in denominator is greater than 0, and so the limit is positive infinity, or simply you can say infinity. Now look at this question. We want to find limit of x to the 3 minus 2x over x plus 2 to the power of 2 as x approaches negative 2. Again, we start with direct substitution. If we plug in negative 2, in numerator, we have negative 2 to the 3 minus 2 times negative 2. In the bottom, we have negative 2 plus 2, all to the 2. We have negative 8 plus 4 in numerator, which would be negative 4. The bottom is 0. So the limit is infinity. But is it positive infinity or negative infinity, or maybe the limit does not exist? Do you remember this question? When we had this two-sided limit, the answer was does not exist, not infinity or negative infinity. So here which case happens. Is it infinity, negative infinity, or does not exist? Because this is a two-sided limit, the limit can be also does not exist. These type of limits, the answer of these type of limits is does not exist if the right limit and left limit be different than each other. One of them positive, the other one negative infinity. But attention here. When x approaches negative 2, it can approach negative 2 from the left, or it can approach negative 2 from the right. This doesn't affect the numerator. The numerator is a number and it is negative. We know this. But the bottom matters. When x approaches negative 2 from the left or from the right, because we have a bracket that is raised to the 2, in either case, the result of this bracket cannot be negative. So again, why never the denominator of this fraction is negative? Because the denominator, if you attention, is something to the power of 2. If this expression is negative or positive, when you raise it to the power of 2, the result is always positive. So here, always the denominator is approaches 0 from the right. It cannot not approach 0 from the left. Never the denominator is negative. Now look at your fraction. In the top you have negative, the bottom is positive, so the limit is negative infinity. This is different than the question that here we had. Here in this question, the denominator can be positive or negative depending to x. If x approaches 2 from the right, the denominator is positive, like here. If x approaches 2 from the left, the denominator is negative. But this doesn't happen in this new question. Why it doesn't happen? Because the denominator is something to the power of 2. So you have to attention to this point. Let me show you an example that is different than this. Let's say we have a limit x approaches 1. In the top we have x to the 2, x to the power of 2 plus 3x. In the bottom we have x minus 1 to the power of 3. We will see the difference between this question and the previous question, and it helps you to understand both of them better. When we plug in 1 for x to find this limit, we have 1 to the 2 plus 3 times 1 over 1 minus 1 to the 3. If you simply calculate numerator, it's 4, the bottom is 0, so we can conclude the limit possibly is infinity or negative infinity. But there is a problem here. When x approaches 1, if x approaches 1 from the right, it would be different than x approaches 1 from the left. Let me write the function again here and here. Numerator is 4, but attention to the denominators. When x approaches 1 from the right, x is a number greater than 1, like 1.1. Minus 1 would be positive, so it's 0 from the right. But here is 0 from the left because x is close to 1 but less than 1. Something like 0.9 minus 1 is negative, and negative raised to the 3 or raised to the 1 or raised to the 5 or raised to the odd numbers, generally it would be negative. So this means this limit is infinity, this limit is negative infinity. As you can see, the right limit and left limits are different. So what would be the answer of this question? The limit does not exist. But here, in this question, the limit was negative infinity. That's true that when we say the limit is negative infinity, also we can say the limit does not exist. But this is different than this other question. So you have to attention to this. Now let me show you another type of functions that their limit at some points are infinity. Probably from pre-calculus, You remember graph of log function or ln of x. Graph of log function, depending to their base, is like this, or it can be like this. Both of them pass through here, which is 1. So the other one, let me write it again. Log x base b. But when we have this curve and when we have the other one, it's good to remember the graph of log functions. Most of the log functions that we see in math are like this one. And log function, the graph of log functions is like that when the base of the log is greater than 1. But if the base is a number between 0 and 1, like 0.5, 0.2, something between a number between 0 and 1. So if the base is between 0 and 1, then the graph would be like this. But what matters here for us is that in both of these cases, the graph of log function goes to positive infinity or goes to negative infinity when x approaches 0. When x approaches 0, the graph of log function goes maybe to positive infinity or maybe to negative infinity. So the limit of the log function is infinity. And it depends to b. If the base of the log is greater than 1, the limit is negative infinity. If the base is between 0 and 1, the limit is positive infinity, as you can see in these graphs. So we can write this rule for ourselves here. Limit of log function with base b, which usually base is greater than 1, as x approaches 0, only from the right. Because for log function, log x, x cannot be negative, so x can only approach 0 from the right. This limit is negative infinity. When the base is greater than 1, we have this curve. And as you can see, when x approaches 0, the y goes to negative infinity. You need to know this rule and keep it in your head. Log x base 3 as x approaches 0 from the right is negative infinity. When the expression here approaches 0, the limit of log is negative infinity. Keep this in your head and you can use it to answer questions. But if the base was between 0 and 1, the limit is positive infinity. But it rarely happens. So I just wrote this rule here. This rule. And don't forget, ln of x is also a log function. Probably you remember, ln of x is a log function, but it is a special type of log function. The base of ln is e, and number e is 2.7. So ln of x falls in which category? Is it a log with base greater than 1 or less than 1? Obviously the base for ln of x is greater than 1. So we can make this rule for ourselves also. Limit of ln of x when x approaches 0. We can consider it as an example. Limit of ln of x also when x approaches 0 from the right is negative infinity. These are just examples of this general rule. Look at this other example. What is limit of? We want to find this. What is limit of ln of x minus 4 as x approaches 4 from the right? When we do direct substitution, the expression here approaches 0, 4 minus 4, 0. And we remember this rule. If the expression here approaches 0, it doesn't matter x approaches what. What matters is that this expression here, if this expression approaches 0, the limit of ln function is, log function is negative infinity. So now look at this. When x approaches 4, the expression in front of ln approaches 0. And when the expression here approaches, this expression approaches 0, 0 from the right, because x approaches 4 from the right, the limit of ln function is negative infinity. This means what? This means that for this function, for this ln of x minus 4, for this function, let me write it down here, for this function, x equal 4 is a vertical asymptote. Whenever limit of any function, when x approaches a, b, any number, is infinity, that number, x equal that number, is vertical asymptote for that function. But I told you, we will discuss more about this in the video of infinite limits and vertical asymptotes separately. But it was good to mention it here as well. Now look at this question. We want to see what is the limit of ln of cosine of x as x approaches 3 pi over 2 from the right. First, we do direct substitution to see what is the limit. If we do direct substitution, cosine of 3 pi over 2 is 0. If you remember the unit circle, 3 pi over 2 is here. And when x approaches 3 pi over 2 from the right, it means that we approach 3 pi over 2 from this way. Because 3 pi over 2 from the right means that x is in an angle greater than 3 pi over 2. Here in this region, we have angles greater than 3 pi over 2. Here are angles less than 3 pi over 2. So you have to suppose x is somewhere here, for example. X approaches 3 pi over 2 from the right. Cosine of 3 pi over 2, cosine at 3 pi over 2 is 0. If we consider this angle, the cosine of 3 pi over 2 is 0. But x approaches 3 pi over 2 from the right. So we want to figure out this 0 is 0 positive or 0 negative. Is it greater than 0 or less than 0? 3 pi over 2 from the right again is in this quadrant, is in quadrant 4. So let me erase and clean here a little. So 3 pi over 2 from the right is in quadrant 4. In quadrant 4, the cosine is positive. If you remember that all students take calculus, in this quadrant, C, which is for cosine, means that cosine is positive. So we know that anyway. Cosine is positive in 4th quadrant. So this means that cosine of x, when x approaches 3 pi over 2 from the right, approaches 0 from the right. Why it is important to consider this? Because if this 0 was with 0 from the left, then we had a negative expression here. And ln of negative is undefined. But here x approaches 3 pi over 2 from the right and cosine is positive, so it's 0 from the right. So, do you remember the rule that we learned here? When we have log function, if the expression in front of the log approaches 0, the limit is negative infinity. Here we have this situation. We have ln, which is a log function. Expression in front of ln approaches 0 from the right. So what is this limit? This limit is negative infinity. Another way to figure out 3 pi over 2 is from the right and figure out it's 0 is to remember graph of function y equals cosine x. Really, remembering graph of basic functions, sine, cosine, log, exponential functions, is really helpful in calculus. Graph of cosine, if you remember, starts from 1, it goes up and down. Here is a full cycle and it is 2 pi. This point is 3 pi over 2, here is pi over 2, and here is pi. When x approaches 3 pi over 2 from the right, so we approach 3 pi over 2 from this way, from right. So we are somewhere here. As you can see, first of all, at 3 pi over 2, cosine is 0. But when we approach 0 from the right, cosine of 3 pi over 2, as you can see from the graph of cosine x, it's positive. Let's move to another question. We want to find limit of cotangent x. We want to find limit of cotangent x as x approaches 0 from the right. Immediately you need to remember cotangent is cosine x over sine x. The other way that you can do this question is to remember cotangent x and its properties, its graph, but usually students are not so familiar with graph of cotangent, so I prefer to do it this way. So I remember from trigonometry that cotangent is cosine over sine, or in another way, cotangent is the reciprocal function of tangent. So cotangent is 1 over tan. What was tan? If you remember, tangent x is sine over cosine. So cotangent is cosine over sine. So cotangent x is cosine x over sine x. Now, if we directly substitute 0, cosine of 0 is 1, sine of 0 is 0. So this limit is infinity. But is it positive infinity or negative infinity? It depends to the numerator and denominator that they are positive or negative. The numerator is 1, we are done with the numerator, but the bottom is 0 and we have to figure out, is it 0 from the right or 0 from the left? You cannot rely only on here, that because x approaches 0 from the right, definitely the bottom is also from the right. No, you cannot do it that way. But if you remember sine function, and or if you remember again the unit circle, in the first quadrant, all the trig functions are positive. Sine, cosine, tangent. And x approaches 0 from the right, so x is close number to 0 and it's a bit greater than 0, so it's in quadrant 1, and in quadrant 1 all the trig functions are positive, so this 0 is 0 from the right, so this limit is infinity. Let's do another question. What is the limit of tangent x as x approaches pi over 2 from the right? Again, I prefer to rewrite tangent in terms of sine and cosine, because usually we are more familiar with these two functions. If you plug in pi over 2, sine of pi over 2 is 1, cosine of pi over 2 is 0, so you know the limit is infinity. We are sure that the limit is infinity, but is it positive or negative infinity? The numerator is 1, so we know it's positive, but this 0, we have to figure out, is it 0 from the right or 0 from the left? X approaches pi over 2 from the right. One way is to remember graph of cosine x. What was the graph of cosine x again? Look at here. This is the graph of cosine x. When x approaches pi over 2 from the right, it means that we are somewhere here, close to pi over 2, but from the right. As you can see in this area, in this region, cosine is negative, is below x-axis. So cosine is negative. So, do you remember I told you here that you cannot rely on this? Here x approaches pi over 2 from the right. Maybe you think this is also 0 from the right. No. You have to check it. So, the denominator approaches 0 from the left, and so the limit is negative infinity. Another way is to remember unit circle. If you remember unit second, pi over 2 from the right is somewhere here, greater than pi over 2. In quadrant 2, all students take calculus. In quadrant 2, sine is positive, which you can see here. But other three functions, cosine and tangent, are negative. So the cosine is negative, so the denominator is negative, and so the limit is negative infinity. I hope by watching this video you have learned how to find infinite limits.